Hello guys, today I'm gonna be talking about nodal analysis, and I'm gonna solve a problem through it, and I'm gonna show you how to do it, and I'm gonna speak through how to actually solve it through the nodal analysis. And I also use a 4-step method that is really helpful, and it's really good to know. So let's get into it. Nodal analysis. Okay. So first I'm gonna show you. I'm just gonna draw the schematic for the problem. So we have a 5-volt here and there. We have a 15 kilo ohm resistor. We have another 2 kilo ohm resistor. We have 20 kilo ohm here, and then we have a current of 5 milliamps there. Okay, so that's the schematic. So the first step that you want to do is you want to identify the reference node. In this case, and a reference node is basically is like the ground. It acts like the ground. It's the point from where you measure the voltage. So that's going to be here for us. And second, identify the node voltages. So we've got 2 here, so you can label this as V1 and we can label this as V2. And then the third step is to write the Kcl equations. So I'm going to write the Kirchoffs Current Law, which is known as Kcl, that's a short form, on V2 right here. So that will be I, the current passing through 2K, plus the 5 milliamp current equals to current through the 20K resistor. So what this equation is basically saying is, so the current going from 5 milliamps and the current going through the 2 kilo ohm resistor will equal to the sum of those two current will equal to the current passing through 20 kilo ohm resistor. That's basically what this is stating. So we can solve that through so that is V2 over 2K. Now this is just Ohm's law, V equals IR, and we know that I equals V over R. So, and voltage for this point right here will just be V1 minus V2. That's the voltage, and the current. And the resistance is just that. So, as we know from V equals IR, that that current is V over R. So that's voltage over resistance. That's just what that is. Plus 5 equals to, and the current here will be V2 over 20K. It's the same thing, like here. So let's solve it. So I'm gonna multiply everything by 20, both sides, and that will go away. So that will become 10, and it's 10 V1 minus 10 V2 plus 100 equals to V2. That will be, and we know we also know V1 V1 is right here, which is going to be equal to 5 volts. So I can just plug that in right here. So that makes it 5. So that's 50 minus 10 V2 plus 100 equals to V2. That will be 150 equals to 11 V2. And V2 will just be 150 over 11, and V2 will be, let me just do it right now, V2 will be 13.63 volt. So we can use this information to solve for a different, for the current passing through like the resistors there. So, and by the way, the fourth step here is just to solve after you're writing the Kcl equations. So let's solve for the current going through the 15 kilo ohm resistor, which is going to be this is very simple because these two are in parallel with each other. So this is 5 volt here, that's also 5 volt here. So as we know, current is voltage over resistance, so voltage is 5 over resistance is 15, and that will be, let me just do it, which is so that is 0.333 milliamp, and the current through 20k resistor is V2 over 20. That's the V2 is the voltage at this resistor. So that's, and because current is voltage times resistance, voltage is V2 and resistance is 20. So that will be let me do it. Okay, that would be 0.6815 milliamps. So now let's solve for the current at 2k resistor, which is going to be V1 minus V2 divided by 2 kilo ohm, and then that will be equals to V1 is 5 minus 13.63 divided by 2000 equals to negative 4.315 milliamps. So yep, so that's how you work through a problem using nodal analysis. Thank you for listening.